those. Okay. All righty. So what questions do you guys have? Or what would you like to go over? You guys should all unmute so we can just talk.
Hi, Miss Marie. Can you go over like the conditionally convergence stuff?
Yes, I sure can. I'm just going to get a piece of scratch paper here. I want to share my screen. Okay. So that's more people coming. Okay. So let's say that we have, so first of all, the conditional versus the absolute convergence only applies to alternating series. That's the only time. The other series, it either converges or diverges, and that's it. There's no conditional or absolute. This only applies to alternating series, first of all. So all of these ones will be alternating in some way, if I'm going to ask you about conditional or absolute. So here's my thought. When I'm making an example, if I want my series to be absolute convergence, then whatever I make on the bottom here is going to make the series converge even without the -1. So in my mind, I'm thinking, how about if I make this a p series with p greater than 1? That way, without the -1, it would still converge. That's absolute convergence. So absolute is when your series converges even without the alternating part. Okay, so it's absolute since even without it, we converge. So if it converges without the alternating, then with the alternating, it will absolutely converge. Okay, if I want to make an example of a conditional convergence, then I like these p series because they're easy to play with, but I'm going to make a p series down here that, or I'm going to make the part of the p series in the denominator where I know it's going to diverge by itself. So maybe just an n, or square root of n, cube root of n, all of those guys. So without the -1, this is a diverging p series. But with the -1, it's alternating in sign, decreasing in magnitude because of the n down here, limit is 0. So without the -1, it's going to converge. So this converges, but the non-alternating diverges, so we call that conditional. Okay. It doesn't have to be p series. I mean, it doesn't have to be a p alternating series. I could make that maybe a 3 to the n down there. That would be a geometric. So in this one, this would be absolute, because even without the -1, we converge. This one would, since we have that 3/2 to the n, this one is just plain old diverging. It would not pass the nth term test. So this would be diverging by nth term test. So not every alternating series converges, of course. Some alternating series can diverge, but if they do, it can be by root test or ratio test or nth term test. Any of those. Okay. Is that better, Paige? Is that okay? Yes. All right. Very good. What else would you like to go over?
Can you go over the findings? Oh, sorry.
That's okay. Which one, Audrey?
Finding the sum of the alternating series.
Yes. If it says to find the sum, are you talking about like a partial sum, like in some of those? Or are you talking about like finding the sum?
Oh, like the partial sum, like using the first.
Absolutely. Is there a problem that you'd like me to take a look at? Or do you mean
a specific one, just like in general, I
guess? In general, you bet. So I'm going to make up a series. I'm going to make it alternating so that we can talk about error too. So I don't want to go too nuts with it. Maybe let's do this. And let's start at 0 this time. And let's say that they say, let's find the, let's approximate the infinite sum with, let's say, the fifth partial sum. Okay, so the fifth partial sum is the sum of the first 5 terms. So if I'm approximating this, then, or if I'm using this to approximate the series, then I start with the very first term, and I try to be super careful finding this first term, because if not, it's likely going to affect all my terms and I'll be way off. So I'm going to put in that 0 for n and see what I get, right? So -1 to the 0 power, well, -1 to the 0 power is +1. And then 0 factorial is also 1. Remember that 0 factorial is 1. So is 1 factorial. They're both 1. Okay. The next term will be a negative, because when we go to 1 for n, we'll have an odd exponent here, so it'll be a negative. 1 over 1 factorial. Well, 1 factorial is also 1. The next term will be positive. 1 over 2 factorial, which is 2. Or we could just write 2 factorial. That's fine. You could write 0 factorial here and 1 factorial if it's an FRQ. These will be multiple choice on the test. So I'm going to go ahead and show it in that way. -1 over 3 factorial, and then +1 over 4 factorial. That is 5 terms. So that is the fifth sum, the fifth partial sum. So if this was a multiple choice question, we would have to go ahead and work this out. 3 factorial is 3 times 2. 4 factorial is 4 times 3 times 2. And so to add these up, well, the 1 minus 1 cancels themselves out. And then this would be, here's how I would do that. I would have, my common denominator would be a 24. You might have to do a little bit of this little adding for the multiple choice questions on the test. The common denominator would be a 24. I'll need 12 over 24 for the 1/2. I'll need 4 over 6 over 24 for the 1/6 negative. And then I'll need just a 1 for the 1/24. So this is 13 minus 4, so 9 over 24, which is 3 over 8. So the multiple choice answer there would be 3/8. So that is the fifth partial sum, and it approximates the infinite sum. That's how that works. Now, in another question, I might say, instead of approximate the infinite sum with the fifth partial sum, I might say, what is the I guess maximum error that it could possibly be. So if I was talking about error, and always know there are 2 ways to write error, either the word error, which is nice, but I do need you to recognize this as error as well. So either one, it's either the partial sum minus the sum or the sum minus the partial sum. Since we have it in absolute values, it doesn't matter. I usually write it with the sum first, but it doesn't matter. So this will be less than or equal to the absolute value of the first omitted term or unused term in the partial sum that we found? Well, the first term that we did not use was the -1/5 factorial, right? So that will be the absolute value of -1/5 factorial, which is 1/120. So that would be the error in that partial sum. Okay. The next thing that I might ask you to do is to write the interval that the actual sum must lie in. And if I want the interval that the actual sum must lie in, I pull out this and I make it less than or equal to this 1/120. So I'll pull that out. S minus S sub 5 is less than or equal to 1/120, or 1/5 factorial is fine. And so now I'm removing this from the absolute values. So I'm getting rid of the absolute values by putting what's inside the absolute values between the negative and the positive of that 1/120. And that's just because that's how we get rid of an absolute value, right? If we had that, to get rid of the absolute value, we would say x is between -5 and 5. All of those values make this true. So that's all I'm doing here. All of these values make this true. And then we add S sub 5 to all sides. Like that. And now I have the interval that the actual sum must lie in. I guess I could actually figure that out, but I don't think I'm going to make you do that on the test. So I'm not going to go that step. But I could like get two fractions that are boundless. Okay. The other way that I can ask you that question, or a question about error. Whoops. The other way I could ask you a question about error is if I give you a series. Let's make it n to something. N to, what do you think? 4? Something like that. And this time, let's start with 2. And let's approximate the sum. It'll say approximate the sum with an error less than, let's say 0.001. AP seems to like 0.001. So we want the error to be less than, just less than 0.001. Okay. How many terms? It'll say how many terms. These make good multiple choice questions because it's easy for me to put some choices down there. How many terms? So 0.001, the first thing I do is I change the decimal to a fraction because that will help me, because my series is in a fraction form, so this will always help me know when to stop. So I'm going to start writing terms until I get to a term that is less than 1/1000. So I want the denominator to be bigger than 1000. So when I start, I'm going to start positive because I'm putting 2 in for n. 2 is even, so -1 to an even number will be positive. So I'm starting positive, and I'll have 2 to the 4th. 2 to the 4th is 16. The next term will be negative. 1/3 to the 4th. Well, 3 to the 4th is 81. Next term will be positive. 4 to the 4th. 4 to the 4th, and you might need to go off to the side and do a little multiplying, and that's fine. That's a big jump. We're jumping big now. This might do it to us. If I put 5 in for n, I'll have 5 to the 4th. And 5 to the 4th is, I think, 625. So we're almost there. I think the next one will do it for us. The next one will be positive 1/6 to the 4th. I don't know what 6 to the 4th is, so I'm going to come off to the side and wish me luck here. So 6 squared is 36. 36, 18 plus 3, multiply by 6 one more time. And I know at this point I'm going to be bigger than 1,000, because if I multiply 200 times 6, I'm over 1,000, right? So since I know that, I'm going to pause there and just make that a 6 to the 4th, because I know that that is going to be, the denominator is going to be bigger than 1,000. So this is less than 1 over 1,000. So here is my error. There is my error. Okay. So if it's asking how many terms to use, I'm only going to use the number of terms before the error. Do not use your error when you're counting how many terms. So 4 terms would be the answer. So that covers pretty much everything that I could ask you. Now, since I'm going to be multiple choice, I didn't do the justification on any of these, but the justification would be the 3 things that make an alternating series converge. We're alternating in sign, we're decreasing in magnitude, and the limit is 0. So I just say decreasing in magnitude to 0, and that covers that limit being 0 as well, okay? And by the way, if you were doing an alternating series, if you were just trying to decide if an alternating series converged or diverged, let's say we have this guy, and it doesn't matter what those are. The way I taught you to do it, and I did this because most students like this method. They do 1, alternating, check. 2, the limit is 0. So as n goes to infinity, this goes to 0, check. 3, each term is decreasing. So you can either write decreasing in magnitude, check. Or you could say 1 over the square root of n plus 1, which is the n plus 1 term, is less than the n term, 1 over square root of n. Check. These two mean the same thing. I need you to know both, but you only need to write one of them. So this was how we did it in class. And so we said, therefore, we are converging by alternating series test. Okay, and that's fine, but it means the same thing to say the series is alternating in sign and decreasing in magnitude to 0. It means the same thing. Therefore, converges by alternating series test. Okay, I don't care which way you say it. They're identical to me. So if you're using the alternating series test, you can write it either way. Communication, remember, in this whole course, you can communicate things differently than what I do in my notes. As long as it has the same meaning and you cover all your bases, it's really okay. All right. So that was a great question. I bet you a lot of people kind of like that little refresher on error. Is that okay, or do you want me to go further? Anybody? Okay, what else?
Can you work through number 8 on the quiz? Because like I understand that it's limit test and I understand why. I'm not really I'm confused on the canceling out part.
Yeah. You know what? I don't have that quiz in front of me. Could you read it to me again?
Yeah, sure. It's okay. So 4 to the n minus 1 times n factorial over 2n plus 1, and it's in like a parentheses, and that's a factorial. And
Good.
the first term is 1.
Okay. All right. Okay, so I see the factorials, so I want to use the ratio test. Okay, now I will tell you this, just getting an eyeball, kind of a gut feeling on this. We have two factorials, and factorials are super strong, but they do, even being factorials, one of these is going to be stronger than the other one is. So here, 2n plus 1 is stronger than just n. So in my mind, the denominator is going to control things. It's going to control things to the point that this is going to converge. Okay, now I just need to prove it. So wherever your strength is, kind of zero in on that. So I know if the strength is in the denominator, if it's powerful enough, and this is definitely powerful enough, it's going to make this thing converge. So just getting a feel for how these things work, how these series work. All right, so ratio test, we set up our limit, an absolute value. I start with the n plus 1 term. So I don't think you had a hard time writing the n plus 1 term. This will be just an n. And then this will be n plus 1 factorial divided by, and this is a little piece where students might make a mistake. Remember that you're putting n plus 1 only in place of n. So this is like 2 times n plus 1 all factorial. Okay. And then instead of dividing by the nth term, I'm going to multiply by the reciprocal of the nth term. So I just flip this. And you're right, this is a messy thing to simplify. So we'll try to be careful. All right, so the 4s are not bad. I have this one in the numerator, the exponent is always 1 more than that of the denominator, so that reduces to 4 in the numerator. With this factorial, that reduces to just an n plus 1 in the numerator. And then this thing, so I'm going to come off to the side and do that. So on the bottom here, I'm going to have 2n plus 2 plus that 1. So that's 2n plus 3 factorial. And I'm reducing that with 2n plus 1 factorial. So the bigger one is on the bottom. So that'll be 2n plus 3. And I'm going to write the next lower term, 2n plus 2. And then 2n plus 1. And I recognize that's the same thing I have on top. So I stop, make that a factorial. And I know that's going to reduce like that. So I just have 1 on top and this on the bottom. So I'm going to come back to my other piece. I just have that on the bottom. So 2n plus 3, 2n plus 2. I know that you guys didn't do a whole lot with factorials last year, did you? Is that correct? Okay, so I get it, and it's good. We will do some more in the next unit. There is often an FRQ where you need to simplify a ratio test on the AP exam. So it's in our next unit, so we'll also have X's up here, but we'll go over it again there. But this is a good little practice for us. Okay, now we're going to let n go to infinity. As n goes to infinity, the highest term on top will be a 4n. The highest term on the bottom will be a 4n squared. And the n squared will rule. The infinity goes down here, so this whole thing is 0, which is less than 1. So we converge by ratio test. Which again, I kind of figured would happen. I kind of figured we'd converge. So that's good. So it's kind of messy. Do not expect one that messy on my test. All right, what else? Good question.
I was wondering if there was going to be any of the integral tests where we have to find like the integral of where the sum lies on the test.
You know what? I don't think I did put that on there. I wish I had. It wasn't intentional that I didn't, but I don't think I put that on there. But in general, when you're using the integral test, and let's say that we have, I'm just going to call that f of x. Let's say that we got some, I'm going to call it capital A. Okay. Let's say that we got that this we found converged to A. If it was a definite, and we'll make it make sense here. So let's say we just got a number. In that case, we can say that our sum lies between whatever this number is. Well, I don't know why I put it way over here. On the left side, it's that number. On the right side, it's that number plus the first term in the series. So that's what you would do there. It makes it kind of a long problem. Again, I should have done, because we have a bunch of multiple choice questions, I should have made one multiple choice question on that, and I just didn't. I don't think, but that's it. Good question. Because we touched on that and then we didn't do a whole lot with it after that, right? So good question. What else?
Can you go over one, like number 4 on worksheet 2?
Absolutely. Okay. Do you mind if I just go over this one? Is that all right? Okay. All right. So this one, here's kind of my thought. My thought is I'm kind of focusing on that piece, and that reduces just to 1/2. And so I'm thinking, my thought is, since that reduces to 1/2, I can just do the nth term test on that one, because it's going to go to 1/2, which is not 1. So it's not geometric because of the +1. So I'm thinking just using the nth term. Let me see, it would make me at least try the nth term test. So for the nth term test, I don't know why I wrote that. I would find the limit like that. So as n goes to infinity, this +1 doesn't matter. And I'm left with that, which reduces to, it reduces to 1/2, right? Just 2 on the bottom. It reduces to a 2 on the bottom, 1 on top. And that is not 0. So we diverge by nth term test. When I see one like that, where as n goes to infinity, I know that's going to, as n goes to infinity, it's going to 1. The limit is going to 1. Think that's nth term test. So limit as n goes to infinity of that is 1, not 0. Same thing here. The limit as n goes to infinity is 1 there. Here, the limit as n goes to infinity, it would be, that would actually be infinity. So we could do this by we could do this by geometric series test or by nth term test. Since this is bigger than 1, as n goes to infinity, this is going to infinity, which is not 0. So diverged by nth term test or by geometric series test. R here would be 7/6. So absolute value of R is greater than 1, so we diverge by Geo test, either one. So I get why you asked me about that, because we don't see it a lot in the nth term test problems, but yeah, that would be an nth term test. Good question. What else?
Can you go over number 9 on worksheet 4?
Yeah. Okay. So when in doubt, with how to proceed, when you have one of these things with K's or P's or something, some other letter going on, when in doubt, to help it make sense in your mind, put in a number for K. Put in a number and ask yourself, what would I do with that? And then use what you would do and then do the problem with the K's. All right, so I'm going to say, let's let K be maybe 5. I don't want to do a 1 or a 0 because sometimes that doesn't tell us a whole lot. So I would do something bigger, not huge, but like a 5. So if I had that, I'd have n to the 4th over n to the 5th plus 1. And now I see, oh, this behaves, so we're going to compare, this behaves like 1 over n. So that's what I'm going to do down here. I'm going to compare with the series 1 over n, which is our diverging harmonic, or you can say diverging p-series, either way. And so then I would say, there are 2 ways to do this. I could let this be a sub n and this be b sub n, and say a sub n is greater than or equal to 0, b sub n is greater than or equal to 0, specifically when n is greater than 1. But that's fine if you don't say that part. That's okay. All right. But I do need you to tell me that both series terms are positive or 0, greater than or equal to 0. And now, since I'm diverging, I look at my denominator, and this denominator with the plus 1, if I did a direct comparison, it would not work, because with the plus 1, it makes this denominator bigger, which would make the whole thing smaller than this. And so I cannot use the direct comparison test. I need to use the limit comparison test. So I'll set up the limit comparison test. I'm going to take this thing and I'm dividing it by 1 over n, which is the same thing as multiplying by n over 1. Now, up in the numerator, when I multiply n to the k minus 1 times n, that's n to the k now. And now this limit, as n goes to infinity, I have the same thing on top and the bottom. The plus 1 doesn't matter. So this goes to 1, which is finite and positive. So my series does whatever this series did, and it diverged. So diverges by limit comparison with 1 over n. So when you get a problem, and AP does like these problems, that's why I try to throw them at you occasionally. If you're thrown by it, try to put in a number for your K or your P or whatever, and ask yourself, what would I do with that? Okay. What else?
Can you do number 22 on worksheet 7?
You bet. Let's grab it. Okay. So they say this is a convergent series for which values of P. So first of all, the 4 on top with the n to a power on the bottom, the 4 on top is not going to affect anything, okay? So it won't affect convergence at all. All I need to do is focus in on this n to the 3p minus 1, which this is a P series. So we are going to converge whenever the exponent, I want the exponent to be bigger than 1. So I set up that little equation. The exponent bigger than 1 will make this converge. And now I just solve this little thing for P. So I'm going to add 1 to both sides and then divide by 3. So P greater than 2/3. Is that all right? Okay, what else?
Could you do number 10 on worksheet 5?
Yes. Oh, yeah. I sure can. So it's kind of a messy one. Again, it's kind of messy. Again, here's my thought process. I have that n factorial on top, and I know it's a factorial, and I know it's super strong. But on the bottom, I have something that's also behaving like a factorial. It behaves like a factorial. It doesn't hit every number, it looks like, but it hits some big numbers. So in my mind, I'm not sure, just starting off, I'm not sure which is stronger, the n factorial on top or this on the bottom, okay? I am going to think, I see that it's alternating, so I'm kind of thinking let's do the alternating series test on this. So we're alternating in sign. I need to find out what this limit is. And this is not going to be super easy, but that's what I need to do. So I have n factorial over this thing. And I need to know, how does this thing reduce? Is it going, in my mind, I think it's either going to 0 or infinity. That's what I'm thinking. So let's do a little work on this. So 2n minus 1, the next number down, the next number that would be here would be 2n, is that right? Is that true? Or would it be 2n minus 3? Which would that be, you guys? Which would that be?
-3.
-3? Would it?
Otherwise, 2n is even, so there's no even numbers in that little order.
True. Okay. Yeah, thank you. Yeah, and now that I started writing that, I don't think I want to do it this way. I think I want to go the other way. I think I want to write out what n is. N is n factorial. If I write it like this, I'd have n times n minus 1 times n minus 2 all the way down to 1, where this would be 2n minus 1 times 2n minus 3 times 2n minus 5 all the way down to 1. Which is bigger, you guys? Which is bigger here, the top or the bottom? And if you're not sure, I'm going to try some numbers. I want to try some numbers. I want to try, let's see what happens when n is big ol' 7, okay? If n is 7, which isn't big, but it'll give us an idea what's going on. I would have 7 factorial on top, and then I would have 2 times 7 minus 1, right? So that would be 13 times 11 times 9 times 7 times 5. I can't count backwards from, okay, is that right? I think so. So we'd have 7 times 6 times 5 times 4 times 3 times 2 over that. Which is bigger? Do you agree that the bottom is way bigger? It is way bigger. And that's only for n is 7. Okay. When n would be larger, it would be a greater difference. So I'm convinced that the bottom is increasing at a faster rate than the top is. So this is going to be 0. And since the bottom is increasing at a faster rate, our terms are decreasing in magnitude. So this converges by alternating series test. Do not expect one like that on my test. I want to see if you know these tests. I don't want you to spend much time on any one problem. Okay. What else? It was a good question, though. I'm glad you asked about it because that was a messy one. What else?
Can you go over number 21 on worksheet 5? I was kind of confused on how to find R in that one.
Yes. Yeah. Okay. So whenever I see a negative exponent, I want to change it to be a fraction, put it in the denominator with a positive exponent. So I'm going to change this. I'm going to leave the 100 on top because it doesn't move. And this will be e to the n over 2. Okay. Now, again, I know that this is a geometric series because I see the e to an n there, but with that over 2, I need to manipulate this to find out what r is exactly. Okay. And one thing that I know to do with this, since it's a divided by 2, I can make it a square root. I can pull it to the root. So this would be the square root of e to the n, and those mean the same thing. Okay, so r here, now I can see what my r is. R would be 1 over square root of e, which is less than, what the absolute value of r is less than 1. So this would converge. Wait, is the absolute value of e, is this whole thing less than 1? Is the absolute value of e greater than 1? I'm sorry, I said absolute value. Is the square root of e greater than 1? Well, e is about 2.7-ish. So if I take the square root, I'm definitely going to be bigger than 1. So yeah, so the absolute value of r is less than 1. So we converge by Geo Series Test. Yeah, that was a good one to ask about. I don't think anybody's asked about that. That's the first time I've done that since like last year. So it was a good one. What else? Would you guys like me just to throw some at you? You can tell me what you would do with it. It's like you're in my classroom and I send you to the board. So, and what would you do with these things? So let's start with just some, just tell me if these converge or diverge and why, that would be the show all your work thing. What test would you use for, what test would you use for this one?
You'd use the integral test, right?
Yes, this would be a good integral test one. Would you like me to go through the steps? Anybody? Okay. What about this one? What would that be?
P-series.
P-series test. So P is 0.3, less than 1. So this thing diverges. For P-series test, I think when P is small, it's going to make my denominator weak, and the whole thing is going to diverge. Diverging P-series. Okay. What about that one?
Geo Series Test.
Good. Geo. R here is pi over E. Bigger than 1 or less than 1?
Bigger than 1.
So we diverge. For this, I know I'm saying the opposite of what I just said, because P was less than 1, so we diverged. R is greater than 1, so we diverged. So the way I think of that in my mind is with the P series, it's the denominator that is weak. Here, for this one, the denominator is still weak, right? Compared to pi, the denominator is weak, so we're going to diverge. So if the denominator is weak, then R is bigger than 1. Another way to think of that is the top is strong. If the top is strong, we diverge. Anyway, okay, what about this one? Haven't done one of these in a while. What does this do?
It's a telescoping series.
Good. And all telescoping series
Converge.
This is the only one that I don't need you to show me any work on. If you just say that, you get full credit. 4 points. All right. So that's the one that I don't need to see any work on. What would you do with this one?
So alternating series test?
I would use the alternating series test too. So we're alternating inside. Without the 1 here, I mean, if we take the limit as n goes to infinity, we do get 0. So the limit is 0. And as n gets bigger, the denominator gets bigger, so the whole thing gets smaller. So we're decreasing in magnitude. And so this is a converging alternating series. Question. It is converging. It's an alternating series. Is it conditional or absolute? Conditional or absolute?
Conditional.
So that, good. It is conditional. So remember, for that one, we ask ourselves, what is the series without the alternating, without the -1? Does that converge or diverge? Well, without the -1, it compares with 1 over n, which diverges. So this is diverging. And if I had to say very briefly why, I would say compare with 1 over n, diverging harmonic. Okay. And that's all I would say. I wouldn't go through anything more. So this would be conditional. Now remember, you don't have to say conditional unless I specifically ask you to state conditional or absolute. All right. Otherwise, you just say converges. Let's see, what else? What would you do with this one? This one will be on the test. I don't know what number it is, but it's there. And I'm sure I put some boundaries here. It's there. So what do you do with this one?
Nth term test?
Nth term test. Take the limit as n goes to infinity. And that is equal to?
E.
E, which is not 0, so we diverge by nth term. Okay. Let's see, what would you do with this one? I tried to play with it. What test would you use?
Would you use the ratio? Oh, yeah, ratio.
I would either do ratio or root, either one, definitely. Okay. Now that you've practiced a little bit, I'm hoping, if you're here, you probably practiced a little bit. I will tell you, when you're doing the ratio or root, and both of those have that limit, what you get for your limit is the same whether you use the ratio or the root test. You always get the same like number or fraction or answer there for your limit, okay? And if I'm looking at this, I don't see any factorials. So I will tell you without writing a single thing down, I know what this limit would be, because the negative one will not affect things because we're going to be taking an absolute value, won't affect things. This n+2, if you're using the ratio test, you'll have like an n+3 on the bottom and an n+2 on top. And when you take the limit, those go to 1. This will go to 1 when you take the limit, okay? And then same thing with the root test. The nth root of this n+2 is 1 as n goes to infinity. So the negative one won't matter. Any n and squared and cubed and to the 4th, whatever, none of those will all go to 1. And you're going to be left with this without their exponent. So I already know that this is going to be 3/4. That limit will end up being 3/4, which in this case is less than 1. So we're going to converge by ratio test or root test. Ratio or root, whichever one we used. Okay. If I have a factorial, then that totally rules. And I'm either going to get 0 or infinity here. If there's a factorial here or an n to the n, then that will rule. And I will get either 0 or infinity, depending on where it is. If it's on top, I'll get infinity. If it's on the bottom, I'll get 0 for that limit. Okay. Now, I need you to show me the work, but it's kind of nice to know where these things are going, okay? Do you want me to do the work for that one? Anybody? Okay. What would you do for, get another piece of scratch paper. What would you do for, let's say, this? Yeah, that's a nice one. What would you do for that one? Which test might you use?
Could you use nth term test for that one?
If you try the nth term test, I always want to write n. If you try the nth term test, what do we get? What is that limit?
0.
Yeah, we do get 0, which means we can't use the nth term test. If you try it and you get 0, you can't use it. We just want something that's not 0 there. So we try another one.
Root test.
I might try the root test. Let's try the root test. Nth root, absolute value of what I see. Okay. So here's my thought. I'm going to have the nth root of n. Well, you know what? Let me just write it out. I'm going to have the nth root of absolute value of n, which will just be n because we're always positive, nth root of n, over, when I apply that root here, I just get a 3. Okay. And if it's, remember, if this is just an n squared, n cubed, these are always going to 1. Those guys are always going to 1. So this is just 1/3. Less than 1 converges by root test. Ratio test would also work really well there. For the ratio test, n+1, 3 to the n+1, times 3 to the n over n. And when we simplify this, the 3's are going to reduce and leave me a 3 on the bottom. The n's do not reduce, so I just leave them. And now I let n go to infinity. As n goes to infinity, this goes to 1, and still we get 1/3. So we get the same result. okay? When I'm doing that root test, I usually just leave it like this, and I go ahead and take that limit. So I say, okay, limit as n goes to infinity, the nth root of n is going to be going to 1. The nth root of 3 to the n is going to 3. So this is 1/3. I usually don't rewrite it. I'll just do it like that. Anyway, let's see. Which test would you use for this, you guys? Which test would you use for that one?
Limit comparison.
Limit comparison. What does this behave like? What would you compare it with?
1 over n squared.
Very good. Okay, so you would have to say both series terms are greater than or equal to 0 for whatever my n values are. And then you would set up the limit. And do set it up. Don't try to combine too many steps in one. On the quiz, I had a student who, one of my virtual students, at this point, they went ahead and multiplied the top by n squared. So they made this like n to the 4th, n cubed, n squared there. Don't do that. I mean, go ahead. AP will need to see your form. This is considered the form. You don't have to put it on the bottom here. You can multiply by the reciprocal, but they need to see that form, okay? They call it form of the limit comparison test. So, or form of the ratio test. Always set up your ratio test. You know, you always get a point for the form. So if it's an FRQ. So be sure to show that form. Don't try to do too many steps in one. But at this point, I would go ahead and just say what the limit is. The highest degree term will be 2n squared, 2n to the 4th. The highest degree on the bottom is 4n to the 4th. So this is 2 over 4, or 1/2, which is finite and positive. So we do whatever this does, and this was a converging P. So this converges by limit comp with 1 over n squared. Trying to think what else. What could you do on this one, you guys? Well, what test might you use?
Could we use direct comparison test?
I think we could on this one. Either direct or limit for this one. If you do direct, either way, you're going to be comparing it with either 1 over n cubed. If I'm doing the limit comparison test, I would compare it with 1 over n cubed. But if I'm doing the direct comparison test, I would probably keep the 10 on top, okay? I know that that's going to help make where I'm only looking at the denominators. This is still a converging P series. The 10 doesn't change the fact that this is a converging P series, okay? And then I would say that both of these series are greater than or equal to 0. For n greater than or equal to whatever this is. Let me give this a number, 1. And then for the direct comparison test, I would compare this one with that one. And that's what I mean. The 10 up on top is going to make it nice to directly compare. It's always nice when my numerators are the same if I'm comparing directly. So the denominator is bigger, so the whole fraction is smaller, and I'm smaller than a converging series. So smaller than a converging converges by direct comparison with 10 over n cubed. If I was doing the limit, I would just compare it with 1 over n cubed. Although I could compare it with 10 over n cubed, I would just compare it with 1 over n cubed. And then you would get you'd be multiplying by n cubed over 1. So this would give you a limit of 10, which is finite and positive. And so converges by direct comparison. I'm sorry, by limit comparison as well. So either one would work there. That may have been one of each type, but anyway. Anything else you'd like to go over, you guys? Any questions on any more of those multiple choice? Some of those multiple choice questions were tricky. Let's see. Oh. Oh. We did a lot of, in this unit, and every limit was n was going to infinity every time. Just to keep us honest, let's do another limit where we'll have x going to, let's just do x going to 0. And I'm going to put tangent x minus x on top. And I think I'm going to put x squared plus 3x on the bottom. Just to keep us honest with our limits. What do we do on this? Do you agree that you'd try to just put 0 in first? I'd try to put 0 in. If I put 0 in, tangent of 0 is 0. 0 minus 0 is 0. And on the bottom, I have 0 plus 0, 0. What do we do when we get something like that?
Do you have to do L'Hopital's?
L'Hopital's rule. So we're going to do L'Hopital's rule, which means we keep our limit, we rewrite the limit, and we're taking the derivative of the top and the derivative of the bottom. So the derivative of tangent x, gosh, it's been a little while now. It seems like it's been a little while. Derivative of tangent is secant squared, right? Derivative of x is just 1. And then here we have the derivative of x squared is 2x. The derivative of 3x is 3. Now we try to put 0 in again. Secant of 0. What is secant of 0? That's 1 over cosine of 0. Well, cosine of 0 is 1. So this is 1 squared, or 1. Uh-oh, we got 0 again. When we put 0 in the denominator, though, we get 3. So that's good. Now I can put an equal to sign because this thing is just 0. I would consider that a flash from the past problem. What is the sum of How do we find the sum of that? Find the sum.
Would it be A over 1 minus R?
Very good. We remember that formula. A is your very first term in your series. So take your time and put 2 in for n, and that will give you A. So we'll have e to the second divided by pi to the third. So that's our A. It's messy, but that's our A. R, remember you can just look at this and see R. There's R right there. R is just e over pi, which by the way is, the absolute value is less than 1. I made sure when I made the problem up that it would converge, because if that's not true, the sum would be either positive infinity or negative infinity. Okay. So now we have 1 minus e over pi. To simplify this, I'm going to multiply top and bottom by pi cubed. Up on top, we have e squared. On the bottom, don't forget to distribute it. So you have pi cubed minus e times pi squared. And that would be the sum. It seems like I had a couple of those on the test, probably because they're easy to write and yeah, I do have a couple of those. I think I have 2 of those. So anyway, they're easy to write. Okay, anything else? Are we feeling all right? Are we feeling overwhelmed or okay? Or somewhere in the middle? Sabrina, you look all cozy.
Yeah, I am.
That's good. All right, guys. Well, if you don't have anything else, I'm going to let you guys go. All righty. I will. Okay, well, tomorrow's the test. So did you guys know we're going to have a faculty meeting on Thursday? And there's a chance that we're going to be going back to 1 lunch after the 4th 9 weeks. I mean, after the third 9, not after the 4th, after the third 9 weeks, after spring break. So I'm really, really hoping, because that would be awesome. I would love to have lunch tutoring again. Oh my gosh. So I'm hoping. We'll see. I hear that that's one of the things they're going to tell us about at our faculty meeting. So we'll see. Okay, guys, I will see you all tomorrow. All right.
Thank you.
Thank you.
You're welcome.
Bye.
Thank you.